Modern interiors are designed to feel effortless. We walk through kitchens and offices filled with handleless, flat panel cabinets that open and close with a silent, heavy precision. Because we rarely see the hardware responsible for this movement, we tend to view hinges as simple pivots, basic metal joints that haven't changed much in centuries. But the hardware inside a modern cabinet is actually a sophisticated assembly, managing intense spring tension, hydraulic fluid, and precise vertical loads. The serene appearance of a modern room is a carefully maintained facade, relying on mechanical systems that are constantly working to counteract gravity and kinetic energy. This diagram shows how the gap between a door and its frame, the reveal, is calculated to the millimeter. Whether a door covers the cabinet edge or sits flush inside it, that entire architectural look is determined by the specific geometry of the hinge arm. To make the hardware disappear, cabinet makers must first remove a significant portion of the door. They use specialized bits to bore massive 40mm craters deep into the wood to house the hinge cup. While older exposed hinges can often swing 180 degrees, the complex linkages in a concealed hinge usually hit a mechanical limit at 110 degrees, stopping the door abruptly to protect the internal components. Modern cabinetry trades that wide range of motion for a cleaner exterior, accepting the internal destruction of the door to hide the mechanics of the pivot. In Euro-style frameless cabinets, the lack of a hardwood face frame changes how loads are carried. The screws are driven directly into the side panels, which must withstand constant lateral shear forces every time a heavy door is pulled open. A self-closing hinge uses high-tension springs to yank a door shut, but a modern soft-close system instantly intercepts that momentum. A tiny hydraulic piston compresses to absorb the energy, slowing the door to a crawl just before it hits the frame. There is a specific mathematical threshold, usually between 10 and 20 degrees, where the spring tension overcomes the door's inertia. At this point, the hinge takes over and finishes the closing cycle on its own. This makes the hinge an active manager of kinetic energy, slowing down or speeding up the door's mass to prevent damage to the cabinet structure. In industrial settings, the concealed design serves a different purpose. Because the mounting points are internal and inaccessible when the door is closed, these hinges protect sensitive equipment in utility boxes and server racks from being tampered with or pried open. This loading test schematic shows how industrial-grade hinges are rated for heavy use. A single hinge made from cold-rolled steel can be engineered to support up to 90 pounds, allowing it to hold wide, heavy panels without sagging. For cabinets that require frequent servicing, these hinges use quick-release pins. These allow a technician to quickly eject the pin and remove a heavy steel door instantly, providing full access to electrical panels or wiring. What began as a tool for kitchen aesthetics has become a standard for industrial enclosures, where durability and rapid access are the primary requirements. This close-up shows the primary adjustment screws in a standard cup hinge. These cams shift the door across 3 axes without removing fasteners. A single turn moves the panel by fractions of a millimeter, allowing perfectly uniform gaps between wide rows of doors. These built-in adjustment points ensure that even if a cabinet settles or a door warps slightly over time, the alignment can be restored with a few simple rotations. Once you understand the forces at play, a quiet kitchen or rows of server cabinets look much more active. You can almost hear the mechanics in action, the snap of high-tension springs, the hiss of hydraulic dampers, and the tension of cold-rolled steel holding 90 pounds of dead weight. These devices operate silently in the background, ensuring that our daily environments remain stable and predictable.